G'day folks, welcome back. This afternoon we're going to take a look at the calculations required in order to pass the CN assessment. So the CN is your non-slew crane greater than 3 tonne. When we take a look through the CN, there's a couple of different load charts that we need to take a look at, and we need to understand it. Now you've got to remember, when you are operating a crane, the load chart is probably your single most important document. So you should have a really good understanding of how to read the load chart. Now the two load charts we're going to take a look at, that you will be looking at through your CN license, is the Tidd, the PC28, and we will also be taking a look at the Franna, the AT20. Now the Franna is a very common crane here in Australia, and it's a good idea to have a good thorough understanding of how to read that load chart. So we'll start with the Tidd load chart and then we'll move into the Franna. Now when we take a look at the Tidd load chart, we'll use a scenario. We're going to be unloading a truck. Let's say we're straight onto the truck, so no articulation. We've got 10 metre boom length, and let's say we'll work with a 5 metre radius. Okay, now I'll use those figures because it'll be easy for me to remember when I come back to it. So we've got a 10 metre boom length and a 5 metre radius, and we've got 0 articulation. So the first thing you need to do is make sure you start looking at the right load chart for your configuration. Now when you look at a Tidd load chart, we'll grab this one here. Now this is going to be a bit hard for you to see, so I will put them up on the screen in a bigger format so you can actually see what I'm looking at. So with your Tidd load charts, you'll notice there are a few load charts in here. So we've got 3 of them in this particular document. Now each load chart, up in the top, it'll tell you the configuration. So on this first one, it says we've got the counterweight mounted on the front, and it's in pick and carry. All right, so as I said, we're going to have the counterweight on the rear, and we are going to be stationary if we're unloading the truck. So we're probably not going to use that load chart. All right, so we'll flip it over. Next one we're going to see is the counterweight's mounted on the rear, and it's pick and carry also. All right, so again, we've now got the counterweight in the right position, but we're not quite there. So we'll go down to the next one. We've got the counterweight on the rear, and we're stationary. Okay, so that's the load chart we're going to be looking at. Now, the load chart number, if you have a look in the top corner, the LMI duty or the load chart number is 10175. So that's going to be one of your questions, is to make sure you're looking at the right load chart. They'll ask you the load chart number. So that's where you're going to get that number from, is off the actual load chart. It will tell you what number it is. So in this instance, we're stationary, and with the counterweight mounted on the rear, the LMI duty is 10175. All right, now when we look at the load chart here, you'll see it's a pretty colourful load chart. Now each of those colours do represent something, so we need to know what they represent. If we look down in the bottom corner, it gives you a little outline of what each one represents. So the orange in this instance is for 0 to 10 degree articulation. The yellow goes from 11 to 20, the green from 21 to 30, and the white from 31 to 40 degrees articulation. As I said, when we pick it up, we are going to be straight ahead, so we're not going to have any articulation. We're going to have a 10 metre boom length and a 4 metre radius, I believe I said. Well, we'll stick with 4 from now on. So, when we look at our load chart, we always have, across the top, we always have our boom length, and down the side, we have our radiuses. So what you need to do is you go across to the 10 metre boom length. So 10 metre boom length, come across here, and we come down until we're at a 4 metre radius. 10 metre boom length, 4 metre radius. We are good for 13,280 kilos. Keeping in mind we're looking in the orange because we have 0 degree articulation. Now that is what the crane is good for. Now obviously we need something on the crane in order to lift it. So it's going to need to have a hook block on it, going to need to have a hook on it. We need to take those weights off that total capacity, and whatever's left is the load that we can actually lift. So if we go back to our Tidd load chart, if you open it up to the first page, what you're going to see is if we were to have the 2-part 9.2 tonne hook block, that weighs 90 kilos. So we need to take that 90 kilos off. So minus 90. Okay, hook block's not much good without a hook, so we'll put the 22 tonne swivel hook on as well. Looking at our load chart, that swivel hook is going to weigh 20 kilos. So minus 20. So when we take that off, we've got 13,280 minus 110 would be 13,170 kilos. Well, hope that's right. Should really rely on the calculator. Now, in that situation, you may look at the load chart and say, okay, I'm good for 13,280. You come up to a load that weighs 13,200, you say, I'm good for it. Don't forget you need to take off the weight of those hook blocks and the hook to see what you can actually lift once you've taken those weights off. Because once those are taken off, the remainder is what you can actually lift. Alright, now sticking on the Tidd, let's say I'm now going to reverse out, and as I reverse out I'm going to articulate at 15 degrees. What would I be good for now? Alright, let's take a look. Now what you've got to remember is when we were unloading that truck, the crane was stationary. So we were using the stationary chart. Now that we are actually reversing out, we're going to have to change our load chart to the pick and carry crane because we're no longer stationary, we are pick and carrying the load. So keeping that same boom length and radius, as we reverse out and articulate, we'll find out what we're good for now. So we have to change our load chart over to the pick and carry chart. So let's take a look at the pick and carry chart. Make sure you still got the counterweight on the rear, don't go to the wrong chart. So still got the counterweight on the rear, we haven't changed it. All we've done is change from stationary to pick and carry. So when you look at your load chart number, you're on 101.66. Now we had a 10 metre boom length and a 4 metre radius and a 15 degree articulation. So remembering with a 15 degree articulation, if you have a look, the yellow numbers are from 11 to 20 degrees. So you're going to be looking for the yellow number in this instance. So we go to our 10 metre boom length, our 4 metre radius. Okay, means we are good for 10,860 kilos. All right, so let me just get rid of this one. One day I'll find what I did with my blackboard eraser. In the yellow, 10,860 kilos. Okay. Now, what we want to do next is we want to find out what is the percentage difference between when you're articulated and when you are straight ahead. Now keep in mind, when we looked at the figure straight ahead, we were stationary. That's not the figure we're looking at now, we're in the pick and carry chart. So in our pick and carry chart, let's find out what it is if we were straight ahead. So if we were straight ahead, you've got 10 metres and 4 metres, that's 11,800. All right, now this is where the little bit of maths comes into it. So make sure we've got our calculator ready. Now, a lot of people seem to forget how to work out percentages, etc. So I do it this way and it makes it easier for people to remember. All right, so 11,800 minus 10,860. let's do that bit first. Find out what the difference is. So get on the calculator. If I can get it to turn on. Here we go. So 11,800 minus 10,860 equals 940. So, if you stick to doing it like this, what you'll find is it's a lot easier to remember the process of doing it. So we've got our 940. What we then do is then divide it and then bring this top number down. So 940 divided by 11,800. 0.079 equals 0.079. Alright, all we've got to do now is times that by 100 and then we get our percent. So 0.079 times 100 is going to give you 7.9%. Alright, so that's the quick and easy way to work out a percentage difference. All you do is you take those two numbers away, what you're left with, you divide it back into the big number. Once you get that figure, just times it by 100 and that will give you the percentage difference between them. So the percentage difference from articulated to straight ahead was 7.9% in this instance. Okay, so that's our that's our Tidd load chart. What we'll do now is we'll take a look at our Franna load chart. So with the Franna load chart, here we go, onto this one, our Terex Franna. So a couple bits of information on it. Let's have a look. As you open it up, the first page you come across is a deration chart for a side slope. Now that's pretty important to know, and we will cover that one very shortly. But before we get on to that, I'll just get rid of this off the board. Alright, so now we're going to take a look at our Franna load chart. Now with our Franna load chart, it's slightly different to the set out of the Tidd load chart. So for example, when we have a look at the front page, what you're going to notice is not quite as many colours. Now there's only three main colours you need to concern yourself with. So if we're in the green, that means we've got 10-degree articulation or less. Right, that will also be shown on the computer of the Franna as well as you're operating. It'll have a little diagram of whether you're in the green, or if you're in the orange, it means you're greater than 10-degree articulation. Now the difference on the Franna load chart is the numbers in the white. So the numbers in the white underneath are going to give you the boom angle in that particular configuration. That is until you get down to the very bottom numbers. So on the bottom of the chart, these numbers on the bottom will give you the maximum radius without boom length. So for example, if we go to a boom length of 5.67, so that's with the boom sucked all the way in, go down to the number in the white down the bottom, and it will tell you 3.57 meters. Right? Even though it's on the 4 meter mark, the actual distance that you can reach is 3.57. So those numbers down the bottom, that is the maximum radius with that boom length. So it won't quite exactly make the next number. So it'll be just shy of it. All right, so most things to remember. Green is no articulation. The yellow or orange in some cases, depending on the print. My printer's obviously running a bit low, but green or orange is going to be, yellow or orange is going to be articulated. And the numbers in the white, for the most part, are the boom angle in that configuration. Very important to know that, because that's going to help you later when you try to work out the side slope deration. All right. Other things we need to know on the Franna load chart. All right. We've got all our weights on the front page there. So the weights of the different components. Also it gives you your winch line pull. So with your winch line pull on a Franna, a 20 or a 25 tonne, is going to be 4.2 tonne line pull, which as you can see here, if you have two parts of line, That then becomes 8.4 tonne that you can lift. If you had 3 parts, up to 12.6, or 4 parts, 16.8. All there on that first page. So number of parts of line, and it will tell you how much you can lift with that number of parts. All right, so we'll go over and have a look at the load chart itself now. So we're going to use an example. So let's say we have 10 meters of boom length, right? So with 10 meters of boom length and a 7 meter radius. So we'll use those two. So again, we come across to our 10 and we come down to our 7, and where the two meet, so 10 meter boom length, 7 meter radius, right? You will see that is going to make guys good for 4,400 kilos. All right, we'll take note of that. 4,400 kilograms. All right, and I'm saying, we'll say we're not articulated. If we were articulated, it would be good for 3,750, I think it is, by the look at it. All right, but not articulated, 4,400 with 10 meter boom length, 7 meter radius. Now, if we were to reverse back and we hit a bit of a side slope, then we've got to apply our side slope deration. So our side slope deration, another important figure we need to find out is our boom angle. So 10 meter boom length, 7 meter radius gives us a boom angle of 24 degrees. All right, so you can see it in the white there, underneath the green and the yellow, we have 24 degrees. Pretty important note, 24 degrees and your 7 meter radius. They're the two figures you need to keep in mind when you're working out your side slope deration. Righto. So how are we going to find that out? We turn back, we're going to come across this diagram here. All right, so this diagram here is what you're going to use to work out your side slope deration. Now, in order to do that, when we look at it, you see the angles down the side here. All right, so you've got the angles down the side. All right, you have, let's say, 10, 20, 30, 40, 50, and 60. All right, comes down to the crane, which is down here. All right. Now you'll have your radiuses along the bottom, 1, 2, 3, 4, 5, 6, 7. Now, what you need to do is you need to go to 24 degrees, so that's going to be halfway here between the 20 and the 30, right? And you come down on the angle towards that crane. You will go to your 7 meter radius and you will go up, and where those two meet, you're going to find it inside one of these percentages here. All right, so let's have a look. If we've got 24 degrees, we come down. At 7 meters, we go up. That is going to land us smack bang in the middle of that 30% range. So, if we were good for 4,400 before we hit the side slope, once we hit that side slope, we then need to derate the crane by 30%, as we landed in that 30% range. So, what you need to do is 4,400 minus 30%. All right, so if you work that out, let's have a look. We've got 4,400 minus 30% equals 3,080. Right. So once we hit that side slope, that is how much we're going to be good for, 3,080 kilos. So you've got to remember, you need to take that into account. Look at your travel path, and if you are going to hit that side slope, make sure you derate the crane. Because what you don't want to find yourself is in the position where you do have a 4-ton load on it, you think everything's sweet, you start travelling back or driving forward, you hit some sort of slope, and all of a sudden the crane's only good for 3 tonne, which means it's going to start leaning over that way. As it leans over, the load's going to lean over that way more too, which is going to just make things worse. So always be aware of what that is going to be. Now, a good rule of thumb that I tend to use while I am operating is if I know I'm going to hit a side slope, I'm going to allow 50%, because in most instances 50%, if you halve your load, it's going to take into account that side slope deration. All right. If you do have a lot of stick out and you're boomed up high, all right, so if you look at your chart in that situation, if I find out where I'll put it, all right, it's around here somewhere. There we go. All right. In this very small area, high boom, high angle, you'll find your 60%. So long as you're not in that sort of area, if you knock half of the weight of the load off, you're going to find out it does cover it. But as far as the maths is concerned, we need to find out where we are and then derate it by that percentage. All right, now, next question will be, how could you decrease the amount of side slope deration? Now, if you notice on your chart, if you keep sucking it in, you're going to stay pretty much in that same area. If you boom up, you're going to go from the 30% to the 40% to the 50%. So you will be increasing the amount of deration. So the only realistic way to decrease the amount of side slope deration is to boom down. Now you've got to keep in mind that that is going to also have the negative effect of increasing your radius, therefore reducing your capacity. But in a black and white answer to how can you decrease the amount of side slope deration, the answer would be to slowly boom down. All right, so that's pretty much the Franna load charts as far as you will need for the CN assessment. You just got to keep in mind that load charts are fairly simple, but you need to have a good understanding of them. They are the one thing that are going to save you from doing something silly. All right, so I hope all that helps. So keep in mind there are some extra calculations on the end, and those calculations are taken straight from the dogging assessment. So if you want to have a look at some of those as well, jump over to the dogging calculations video and have a look at them as well, because they will form part of the crane assessment. All right, regardless of what crane you're doing, you're always going to have to do those extra calculations to cover off a bit of dogging knowledge, because it's a good idea as a refresher. I say as a refresher because I believe you should always do dogging and rigging and spend some time under the hook before you actually go out and get a crane license. All right, so they're the calculations you need to know for your non-slew crane. If you want a refresher on the dogging ones, because they will be required as part of the assessment, go over the dogging calculations, have a look at those assessments. And if you do want any other information or you're not sure about something, drop us a line and I'll try and get back to you as well. All right, thanks for your time, thanks for listening, and I'll see you again in the next video.